earlier. I have other copies. Let me do that right now. I think things connect for us here tonight. Part one, what on earth in calculus is this? It's called the difference quotient. Difference quotient. He said, wait, professors, I know what difference implies, you're subtracting. I know what quotient implies, you're dividing. So what on earth do they call something in math difference quotient? You're subtracting. At the same time, there's a quotient going on. And I could give you what it looks like, and sure enough, it looks like that. There's a quotient, and there's a difference going on. But first, before I show you exactly what it looks like and why they call it a difference quotient, let me go back and make a connection for you. Because why on earth go through all this if you don't see the connections? Let me go back to a quick sketch. The graph of a function. Let's say this time it looks something like this. And I say that's the graph of a function y is equal to f of x. We passed the vertical line test, so it is a function. And I could ask you, where is it increasing, decreasing, below the x-axis, above the x-axis, like you did before the break? But no, we could do that definitely. I want something else this time. I want to plot a couple of points. I'm going to plot a point here, guys. I'm going to say on this function, I'm going to give its coordinates as maybe, say out -3 down 2. And I think I'll label this one. Let's see if I want to go up here. Yeah, why not? And I'll label it as maybe out, let's say out 4, up 5. Those 2 points. Now, Susan, Mr. Park, you may want to add some things to this because this is part of calculus. You have a graph again, except this time I'm not asking you about local max, local min, all that business like you did before the break. I'm asking you this. If you take 2 specific points on that graph, and you want to get from this one to this one, and you want to stay on the graph as you travel. You're trying to get from the point on the left to the point on the right, and you're staying on the graph, so you're traveling along the graph to get from one to the other. You're traveling something like this, from the initial to your destination. Is that true? With the 2 points there, if I want to get from one point to the other, that's the way you travel, right on the graph. Please tell me, as you go from left to right, you travel from one point to the other, are there some changes taking place as you travel? Is there a little piece of this, when you first start out, is there a little piece of this decreasing? And then it looks like maybe down here somewhere it might then turn and start doing what? Increasing. So is there a little change taking place there? At first it might be decreasing, and all of a sudden it starts increasing as you travel to get from one point to the other. So there's some changes taking place. What they want us to find in calculus is find the average rate of change as you go from one point to the other. Point this out first. Average rate of change. And I think you're going to be shocked, and I want someone in this brilliant class to tell me, and first I'm going to give you a hint. If they ask you, what is the average rate of change? You'll say, Professor, what do they want? They want the average. Like I'm going to find the average of my scores when I score my exams on Wednesday. I want the average, and I may come back and tell you what the average score was. Out of 80, the average was 20. Now, that would be horrible. So I don't want that to happen. I'm looking for an average. That's what they're looking for here. What's my average rate of change? I know somewhere in here there's some negatives, it's decreasing. Somewhere there's positives indicating it's rising. So it's a little bit of each. And they just want you to add up when this all is happening and find the average. And they call it average rate of change. Now I'm going to connect these 2 points to give you a hint. What it really, really, really comes down down to for students to do, which I love, which is going to make it much easier for us if I connect these here. I'm going to connect those by, it's supposed to be a straight line. Not too bad. I connected those 2 points with a straight line. Can someone tell me, what do you think in mathematics? They're asking you that more than likely you did back in 7th grade, maybe 6th these days, that would help you answer the question, what's my average rate of change as I move from that one point to the other? What do you think it comes down to finding from 6th grade? In the back. Tell me again.
Y equals mx.
Oh, I love that. I'm going to use it. I'm going to use it. Hang on. He says, Professor, the green, I remember, it could be written in the mx plus b form, called the slope-intercept form, where m represents slope. I love that. I can actually name the green line as something with mx plus b. It may be 2x plus 5, negative 3x minus 4, something like that. Now, though, what's the key here, though, to answer the question? He almost had it. In fact, he did too much for me. They're asking for slope. Can you find the slope of the line that connects those 2 points? And who on earth would think that I'm using a 6th grade concept to do a calculus problem? They're asking me to find the slope. Now, you say, Professor, it's been a long time since I've done slope. I have not thought about slope in 10, 15, 20 years. How do you find slope? Well, the symbol is M for slope. I think of it as this. It's the change in y, they call it delta y, over change in x, delta x. Looks like a little delta from the Greek alphabet. Delta y, change in y, and that letter delta, delta x, change in x. Many students will say, Professor, when I taught back in 6th grade, my teacher gave it to me like this. Change in y, written like that. And change in x was written like this. And then some students have been upset with me in previous semesters, say, no, my teacher showed me this, Professor. They wrote it like this. Change in y in this order, and change in x in that order. It makes no difference. You'll get the same answer. The thing is, I need to know which point did you identify as x1, y1, and which point are you going to identify as x2, y2. Me, myself, this is up to me here, I'm going to label this negative 3 down 2. I'm going to let this be my x1, y1 point that we're talking about. And this point over here, 4, 5, I'm going to let it represent x2, y2 point. Or you could have done opposite. Now, can someone tell me, let's use this form. What would y1 subtract y2 look like with numbers based on what I have here? Is it negative 2? Yeah. Subtract 5. And over it says x1 minus x2. x1 in my case is negative 3. And that's subtract x2. Looks like x2 is 4. Yes or no? Yes. Looks like it's a negative 7 over a negative 7. Is that true, guys? Or a slope of 1. Is that true? So what are we going to say the average rate of change is as that point moves, or as you move? Along here on the red, you're trying to get from here to here. This is the initial, this is your destination. As you move, we're going to say on the average you are moving a slope of 1, or 1 over 1. Out 1, up 1, out 1, up 1, out 1, up 1. To get from one point to the other. That's all they want. They want the slope. Now my student in the back helped me out. Thank you. They also want students to find the slope, which is easily done. They also want you now to write the equation for that green line. And he's already given me a hint. He says, Professor, can I use mx plus b? Because they want the green line, guys, they want to know the equation for the line. In fact, they call this, I'll put a word here, They call a line that connects 2 points on a graph a secant line. So a green line, this one connects 2 points on the graph, and they give it a name, secant line. Just line, but secant line. Guys, to write it, can anyone help me out? How would you write the equation that corresponds with that green line?
Y equals X.
Tell me again.
Y equals X.
Okay, hang on now. Y is equal to X, hang on now. And you gotta tell the class why. You say, wait, professor, you made this one simple. It's merely this. Oh, by the way, does this right here look like, when I was graphing all those parent functions, does that sort of look like Y is equal to X? Oh, Ramsey, you're good. Is that what I saw earlier? Y is equal to X?
Yes.
Now, we're going to accept that? And he said, Professor, it's got to be Y is equal to X. Think so? Well, by the way, did I imply it went through the 0, 0, I think? We'll find out, though. By the way, is the slope 1?
Yes.
Okay, so if I want to use the slope-intercept method, the y-intercept, back up here that a student gave me, this is y is equal to the slope we discovered is, where is it? Over here, 1. That's this. So that's 1x. And the b is supposed to represent the y-intercept. Did I sort of imply to go through the origin? Is that the y-intercept?
I don't think that's the actual one, but it looks the way you.
Oh, the way it looks, yeah. Does it look like it might go through the origin here?
But it doesn't.
We're gonna find out, we're gonna find out. If I say it does, make it go through the origin, would you accept that as the equation then?
Yes.
If I did that? Yes or no?
Yes.
So you're saying the y-intercept is 0. Professor, if that graph was drawn better, right? It goes through the origin. Okay. Would you accept that? And that's the equation of the secant line that connects those 2 points. Now, does anyone have, before I leave it, and then we'll try something else here, does anyone have another way that you have seen before you met me? You may have forgotten it. There's another way when the teacher asks you to write the equation of a line. I love mx plus b. Does anyone remember another way to write the equation of a line that I bet when I show it to you, you'll say, oh, I've seen it, but I've sure forgotten it? Does anyone recall? No, something else. And they gave a name to it back then. Does anyone remember how to write the equation for a straight line besides just merely using mx plus b slope intercept? There was something called point slope form. I'm going to try it also on this and see if I get the same answer. What does it look like? It looks like this. Y subtract y1 equals slope times x minus x1. Another way to write the equation of a straight line. I'm going to try it on this and see if I get the same answer as the mx plus b that I used. Guys, this one would be y subtract y1. I think I labeled y1 with a -2 earlier. So this is y subtract a -2. Slope, we found slope to be a 1. And x subtract, I need x1. And I think, where was it? x1, y1 was here. Was x1 3? Yes or no? Did I put those in correctly? Was x1 3?
Negative.
-3. So it's x minus x1 -3, like that. Is that true? Now, students are saying, Professor, that line of yours may be off a little bit because we're going to verify it right now. That's the point slope form. Make sure I put my numbers in correctly. x1, or y1, was -2. x1 was, I had covered up here, was -3. If I clean this up, this is y plus 2, slope was 1, x plus 3. Guys, if I solve for y here and merely move that 2 over, please tell me, would you end up with that? Would you? by point slope, would you end up with y is equal to x plus 1? We said by slope intercept, it was what? Y is equal to x. Did they vary? And that's why I think some of my students would tell me, so Professor, you didn't quite draw that line. You didn't have your straight edge with you tonight to line these things up. You did not draw that line quite what it should look like. No big deal. I think students would tell me it might, I think the point was here, it might look more like, Professor, it might do more like this in the green. See if you guys will agree. Because I did not line them up. Might it do more like that? Passes through this point, passes here, not 0, 0, and passes through here. Might that be 0, 1?
Yes.
Might that be the y-intercept? And that would then confirm that, no, you need to do a little bit more work here with this. Guys, all it comes down to, all I will do tonight is, if you're asked to find the average rate of change, please find the slope. If they ask you in the textbook to go further and write the equation of the secant line, I would, so you will not make a mistake, I would refer to this to write the equation of the line. Y is equal to x plus 1 in this case. Make sense? Okay, average rate of change, slope. Now, what I'm getting to though, what I want to ask you about on the exam Wednesday, is this. With that said, and that idea there, I'm going to do this. Let's go to part 2. Oh, you know what? I'll just continue with this. Let's go to another graph and do this. And let's say the graph this time looks like this. Here goes. Think of a good way to do this. I will label a point here. I will label a point here. You say, Professor, you want to do the same thing you did over there? I will have 2 points. And again, the question is, I need to travel from one point to get to the other. And common sense tells me if I want to stay on that graph and get from this point to that one, you're going to have to go up, decrease, increase. So there's lots of changes taking place as you move from one green point to get to the other. Is that true, guys? And I can quickly find the average rate of change. What's my average rate of change? I see this change taking place, Professor, but what's the average? All I would ask you to do is to find the average rate as you move from one point to the other is this. Please just calculate the slope. That's that delta y over delta x. And guys, I'm going to label mine. It's up to you. I'm going to label this one as, let's say -5 down 3. And let's say this one looks like it might be out, let's say out 6 up 4. And find the slope. Connect those with a straight line. Find the slope, and we'll accept that as my average rate of change. And guys, all I'm looking for right now is on a rough sketch. Connect those with a straight line. They're looking for the slope of that straight line. It's called a secant line. So let's get the slope here. Y1 subtract y2, I'm going to use that form. Change in y over change in x. Now the way mine's labeled, it's up to you. I think I'm going to label this one this time as x1, y1. It's up to you. And let this one be the x2, y2. It's up to you as to how you label them. So I got x1, y1, and x2, y2. And then we'll use this form here. It says y1, mine's 4. Subtract y2, -3. Over x1, 6. Subtract x2, where's x2 here? -5. Guys, check my arithmetic. I'm right on top of the board here. Is it 7 over 11?
Yes.
Is that true? That's the average rate of change. So it says as you travel to get from this point, where is it? from this point to get this point, and you travel along that black graph, you're going up, down, up. The average change is a strange number, 7, 11. That means for every 11 you go out, you will go up 7 on that particular graph, on the average, to get from one point to the other. That's what I'm concerned about. Now, what else am I concerned about? Let's go to a graph. Now, this is where I think I'm close to ending class with this concept coming up. Let's see how much time I have here. Oh, I've got plenty of time. Okay, thank goodness. One more graph. This time, I'm not going to place numbers. I'm going to place 2 points for a reason, but I will not label them with numbers this time. Now, what I'm going to do, I'm going to label a point here, a point here. I will say this is the graph of a function. It will pass the vertical line test. Connect those two with a straight line, of course, as we always have. Let's get that straight line, something like this. That's the secant line, connects those 2 points. Now, I will not use numbers this time. Now watch carefully what we'll do. I will label this first point down here with coordinates. I'm going to call the first coordinate x. If I'm not going to use numbers like I did over here, can anyone tell me a nice, appropriate representation for the second coordinate down there? And I'm not using numbers. I'll use x for the first coordinate. What do you think might be wise to use for the second coordinate and not with a number this time?
Y.
Y. And could I call y even better f of x? Is that y?
Yes.
So could I call this f of x? It's the same as y. Now this point up here, I need to label it like I did the others. Now let me ask you, no numbers this time. Is that point at the top there, is that a different point? It's not the same as the other point, is it? They're not the same, are they? So how do they show this in calculus if they're not the same and no numbers? They label the x as, look at this. Most textbooks will use an h. They will attach an h to this to show that the next point up there is different than the first one. So they call it x plus h, just to show it's different, and it is different. Some textbooks may use different notation. I think your textbook uses an h. Now, can someone be really, really clever and tell me, what do you think the second coordinate would look like?
Yeah.
Thank you. F of x plus h. Now, I'd like to express the slope of that straight line using that standard slope formula. Delta y, delta x, y1 subtract y2 over x1 subtract x2. I'm going to use that version. Now, I think it's a good thing to do this. Yes, why not? I'm going to let this one be my x1, y1 point, and let this one represent the x2, y2. So I can use that formula. Now it's going to look strange, but it's going to give me something I need. Can anyone tell me, I have no numbers to work with like over there, what would y1 subtract y2 look like, this part of my slope, look like based on the way mine are labeled? And it's going to look a little strange. I need to see what y1 subtract y2 looks like the way I have this thing labeled. Yes?
In parentheses, f of x.
F of x plus h?
Yeah,
Okay.
minus.
All right, guys, that's my y1. That's why it's labeled. And then it says subtract from my slope formula, y2. What's y2?
F of x.
F of x. Now, over x1 subtract x2. The way it's been labeled here, x1 is x plus h. Subtract, h in there, subtract, is that the marker? Come on. There. Subtract x2, and x2 is that f of x? Or is x2 x?
Yeah.
Did I put everything in correctly?
Yeah.
Now if I clean that up just a little, I'm left with this. F of x plus h, subtract f of x, all over, x's will cancel in the denominator, and leaves me an h. That's what they call the difference quotient. That's where it came from. So you guys who did look ahead, you say, Professor, I see it on the handout. I had no idea what it was. I haven't used it yet. I've just shown you the derivation, where it came from. So they give a name to this. They call this the difference quotient. And by the way, just out of curiosity, I do see a difference. I see a subtraction sign. And is this thing also representing a quotient? Is it implied division? Difference quotient, but that's where it came from. Now let me see, Susan, Mr. Park. I want to see how clever my class is. I think I've got some clever students. I don't know my students that well yet. But boy, will I get to know you soon. Especially after that first exam. Here we go. I'm going to give you a function, and we're going to try to calculate this thing called a difference quotient for it. I'll show you where the difference quotient came from. So on the side here, I want to give you first this function. I want to find for that function this, the difference quotient. So I can find that. Now, before I jump in, and you're going to help me, that's it. That's what they're actually find. They call it difference quotient. Can anyone tell me what was the first piece of this that I'm looking for that particular given? What would f of x plus h look like? What does f of x plus h imply you do to begin with that we did last week? So what's this little part right here going to look like based on the given? Now before you answer, since my hand's going up though, if I ask you not this, I guarantee if I ask you this, now watch what happens. If I said, class, find f of 5 for me. Suppose I said f of 5. What would you do to find f of 5? Every student in class would say, Professor, you go back and replace x by 5. And calculate and get probably, what, negative 23? That's true, if you replace x by 5? No, this says find f of x plus h. Tell me what's the best you can write down to show that. I didn't give you a number like 5. This one says f of x plus h. What does that look like for this particular function? Anyone?
-4.
-4.
Parentheses x plus h. -3.
Love it. Let me mark this out. That's done. It says go to the function and replace x with x plus h. Really, was that you? Oh, over here. Thank you. Over here. Thank you, thank you. Woo! Now I'm not quite finished. Now it says subtract. Look at this in the difference quotient. Now, that. What am I going to put for a replacement for that? the original function. That is the f of x. So we'll block that off also, just to show it. They're saying, now please put inside here the original function, that's f of x. And that takes care of that. And don't stop there in that derivation. You got to divide all this by what? H. Now, and I think by now you've been with me long enough where you know you're not going to walk out of here and go to a calc class and not be prepared. I've already seen some of the calc instructors crying. They're crying. They say me, Ramsey, I gave them a pretest. What happened? 0. I said, they didn't do anything at all? They got 0 on a pretest the first day? Yep. That's not going to happen. I said, did you have any of my students? If so, I want to see their papers right now. If they got one of those 0s, Mr. Park, I would find you. You Sujan? If you got a 0, I'm going to find you. In fact, these two guys had instructors that I knew. Now, I got to clean this up. If we accept this, guys, this is it. Now I got to clean it up. Do a little algebra here. I see a little distributive property. Distribute the -4, -4x, minus 4h, minus 3. That takes care of that. If you don't mind, let's mark it out. Subtraction sign here. I'm going to change my signs down here, make that a positive 4x and a positive 3, almost like a distributing the negative. That takes care of that. Still over h. I'm just cleaning it up. Doing some algebra. Some of these terms will cancel. Ah, these cancel. These cancel. And I'm left with -4h over h. Tell me from algebra what else is going to happen? The h is canceled. What are you left with? -4. The difference quotient for that function that was given to you is said to be -4. Now, my student in the back, you gave me some input. The function I gave you in this case was this function in the form of this. Mx plus b is a slope to begin with -4.
Yes.
After I crunched all this business out, called the difference quotient, did I sure enough get -4 again? That's slope. Now, if you see on the exam on Wednesday, I give you this. We're not going to work through another one here like this. F of x is equal to 13x subtract 64. And I ask you to crunch out the difference quotient. And you say, wait, Professor, I see the answer right now. What must the answer be without me and you tonight after this beautiful class, without me going through this again? What must the answer be here automatically? 13. I see a smile. I see some smiles on faces. Are you kidding, Professor? That's what we're talking about here, slope. Now, if I gave you this, remember we'll do one like this. If I gave you this, now can anyone easily identify the thing called the difference quotient on this one? No. I'll answer that quickly. What's the difference? Why can I not easily say 13 again, Professor, or whatever, on the second one here, even though I do want to know what the difference quotient is for it, but it's not as easily identified as this one. What's wrong with it? It's square, it's quadratic. So when does it only work that you can easily see what it is? Use the correct word here. What must the function be? Linear. If it's linear, you can tell even before you do your work what the answer is. Would it be wise for me, as an instructor, on your test Wednesday, would it be nice for me to give you a linear? So you would know the answer ahead of time? And after you start crunching and crunching and crunching, and you say, Professor, I know the answer is 13, but I can't get to be 13. At least you know the answer must be 13. Is that true?
Yeah.
Well, of course it would be 13. This one, we're going to do this one. I'll tell you ahead of time, you can't tell what the answer is right now. I don't know, some students may have a little calculus background. Does anyone think they know what I'm gonna finally end up with when I find the difference quotient on x squared subtract 3? No. No. Okay, before I jump into it, can anyone tell me what the difference quotient on that one would be? Pi. Is that in the form of mx plus b? I'm going back to the other one there. You cannot tell me automatically what its difference quotient is. We must calculate it. And this is calculus. Now, what am I going to do? I'm going to use this. So guys, I'm going to take this right here on the side, then we're going to practice a little bit here, and I got worksheets for you. I'd like to find the difference quotient, this, now, if we do this, go out and press your friends who are taking calculus. In fact, some students in this class could help those calc students out. From what I'm hearing, some of them need help. So maybe you show them how to do a difference quotient. And then they would know what they're doing in calculus maybe. Guys, let me erase this. Here we go. And I'm trying to find it for this function here. Now, can anyone give me a start first? Can anyone tell me what that much looks like for this function? F of x plus h, for x squared subtract 3. What does that look like? Just that first part of the difference quotient. Anyone?
X plus h squared minus.
Then we get
X plus h squared minus.
x plus h squared, and you still got the, on the end what, subtract 3?
Yep.
We block that off. Ignacio, I agree 100% with that. That's what it looks like. You go to the function and replace x with x plus h. That's what he said to do, and I did. I replaced x with x plus h. Now, am I finished? No, it says now subtract this. And f of x, that's the original function. Just write it down again. And don't stop there. Divide everything by h. And whatever that comes out to be, that's the best I can do here. It may not look as pretty as 13. Or the other one was, what was the other answer over there? -4. May not be that nice, but when we cleaned up. Guys, I need to clean this up. Here goes. Be careful. This is step 1. Step 2. Can anyone tell me from algebra, what is x plus h quantity squared itself? Just this. What did I give you? X squared, I'll take that. Tell me more.
Plus xh.
Okay, in fact,
2x.
2xh. And plus h on the end, h squared. Guys, I'm gonna mark this out. That's done. That's x plus h times x plus h. Now, I'm not done. Subtract 3 is still there. Now subtract on the end. Guys, this is taking place on the end, so some signs are changing on the end. So we're going to write this as negative x squared plus 3. See if you guys agree. All over h. Now I'll put this in brackets just to point out you would really not need the brackets. You can keep the brackets if you wish. I just want to point something out. You guys agree so far? Now, some of these terms will cancel. Thank goodness, the x squareds are gone. 3's are gone. Now, can someone clever tell me, can I simplify what's left over further?
Yes.
And I'll give you a hint before you tell me what to do. Did, at the end over here, did the h's eventually cancel out? I think the same thing's going to happen over here. But something has to be done first before I can cancel h's out. Does anyone see anything to be done at this point? Let's step back and look at it. All thing I'm left with are these two terms. Does anyone see anything from algebra I could do with those two terms that might help me?
Divide by 2.
No. Divide by 2. Yes.
With the H.
Factor out an H.
Yes.
Do both remaining terms contain an H?
Yes.
Could I take H out? If I take an H out of those two terms, do I have 2x plus H left over? Still over H. I just pulled an H out. That true? From algebra? Now please tell me, am I at a point now where I can do the same thing I did back here on this one, which was, Professor, you finally canceled these out. Can I now cancel out over here on this one? Can I now say these can cancel? Like over there. The answer is not quite as nice as over there, but the answer is 2x plus h. And that's the best I can do for the difference quotient of this quadratic. It's not a nice number like 13 because it's a quadratic. The best I can do is it's 2x plus h. Yasuja, Mr. Park, that's why I have you guys here. You worked so hard for me to begin with. But can you tell the class where they might see this? Because they're going to be traveling to MATH2. I may be traveling with them. Can you tell them where in MATH2 they're going to see this? Say it again. Mention that word too bad. Tell the class.
Oh, derivatives.
Derivatives. You said, Professor, I don't know what a derivative is. I'm so tired just after this MATH2 and barely walk. Can barely get up out of my seat. I'm so tired after MATH2. Now you're already talking about something, she says, something called a derivative. Yeah, it's a derivative. Mr. Parker, you got anything else?
We learned this at I remember chapter 2 in Calc 1.
See, Calc 1.
Yeah, and we plug h as 0, limit of 0.
And then they finally tell you what to replace h by. I'm not going to do that here. Lord, I'm happy enough if you get to this point here. And then they're going to tell you why they're going to let h be 0 and get a nicer answer. In my case, that'd be what, 2x, if I let h be 0. But there's a reason why they let h be 0 in calculus. But you have to wait till you get there to see why they let h be 0. Guys, okay? Now, can these get lengthy? They can get lengthy. I have one of these on the test Wednesday. It's called the difference quotient. Here goes. Mr. Park, did you, I think maybe all those handouts we've passed out? Did I tell you guys a story about my handouts? I don't think this class has heard the story. Suja and Mr. Park, you've heard this story before. I usually do buy copies myself. I usually stop at my local FedEx, and I go and make copies. And I go in there so much, they know me. And the workers in there who are working are students. They're young students who are going to a different college than here, but they are there. And they walk around, sometimes they don't have much to do. They're just students working at FedEx. And sometimes they'll walk up and they see what I'm doing. They'll say, oh, you teach math? I should have said no. I said, do you teach math? I said, oh yeah, I teach math. Yeah, I'm a math professor at Santa Monica College. And so they started talking. I said, who are you? And they introduced themselves. And I said, do you go to college also? Oh yeah, I go to this, and they named the college, and I shook my head, you're at the wrong college. But anyway, since you're there, I wish you the best. Okay? Well, I went in again later on, and two of them this time, came up to me. I thought, well, why are you coming up to me? I'm making copies here. I'm busy. Professor. Yeah, now they know me. They had their math book with them. Their textbook was with them. I said, oh no, here goes. I said, yes, what can I do for you? They said, Professor, we're having trouble with some of these problems in homework. And while you're having the copies made, could you help us? Well, me as a professor with a big heart, I said, yeah, okay. I'm rushed, but I'll help you. So they showed me the problems in the textbook, and we went over to the side as the copies were being made. And I helped them with their homework, and they smiled. And they started leaving. I said, no, you're not leaving yet. And I helped you, now you gotta help me. You're gonna pay for this. You're gonna pay for this. I think all these copies today was $50. I don't know how much those kids make at FedEx. I don't think they make much, but they were there. I said, guys, you gotta pay for these. They make it an allowance of some sort, since they work there. And I may have taken all of their allowance. But I said, okay, no. So when I go in next time, let's see if they come up to me again. Yeah, so that's where all these copies are coming from, FedEx. Okay, guys, here's what I want to do though before we run out of time here. Then I'll be more specific what's going to be on this test Wednesday. Okay, and which parts you might want to leave out. I may have to leave out a few of the things on that review. I'll let you know. But I think you do have this. Guys, check and see if the handout at the top says functions. See if you have that. At the very top says functions. Was that passed out today or was it passed out earlier? Yeah, that's it right there. She has it, says functions section 1.1. I think it's passed out last week. Oh my goodness, hang on to all these handouts. This was passed out last week. At the top of the word functions. Got it last week sometime. Okay, if not, I'll write down what you need to know. I gave you a few examples to do for me to find the difference quotient. Now, I'm going to keep this brief. I'll give you one on the exam on Wednesday to find the so-called difference quotient like we're doing here. This comes down to slope. Now, that handout, and everyone has it, and we'll eventually find it. I need to do this. Not bad. Beautiful. There's enough time here. Let's want to erase this over here. Okay, guys. If you have the handout, the first one given on the handout looks like this. 4x subtract 2. Now, if you're lucky enough on the exam Wednesday to see one something like that, and I ask you to find this thing called difference quotient, please tell me. I'm going to ask you to go ahead and show it, but what must the answer be? 4. Now, I'm going to go ahead and calculate for you right quickly. And then do another one here. This one, though, the answer must be 4, easily seen, slope. So, guys, let's find f of x plus h. Subtract f of x all over h. I'll call this step 1. F of x plus h, be careful, just replace x with x plus h. And then I've got this, minus 2. That's the way that first part, I like to block these things out as soon as I do it. That's how the first part looks. Then subtract on the end, f of x, just repeat the function. And all that's over h. Now, when you clean that up, it better be 4. Now, see if it is. This is 4x plus 4h subtract 2. This minus 4x plus 2. All over h. Terms, x's cancel, 2's cancel. I'm left with 4h over h. How nice, even the h's cancel. There's my difference quotient. Does it agree with what we said it should agree with?
Yes.
Okay. I'll have one also on the exam where you cannot see it before you find it. On the linear functions, you can see it. I'll try one of these and see what you can do with it, and we're going to stop tonight. F of x equal to, I've got x squared, guys, let me make this one a little bit more challenging. It says x squared plus 5 on your handout. I'm gonna do this. And I'm gonna find this. So you guys, with the handouts, I give you x squared plus 5. That's more like what I did over here with x squared, wherever it was. X squared subtract 3 or something over there that we did earlier. This one's gonna be a little bit more challenging, but we'll do it. Now, can I tell right now what the answer is gonna be? No. You, Susan, and Mr. Park might be able to see what it is, but right now, we cannot see it's a 4. It's not a 4. Guys, do it, don't make a mistake. This says, please go up to the function and replace all the x's with x plus h. Since this is my closure to the class probably, that means replace all the x's with x plus h. And I'm going to be very, very, very patient. X plus h. Plus 5, block that off so you can see it. That takes care of the first part of that difference quotient. Subtract now. On the end, you got to do this, which means just repeat the function. All over h. Now guys, this one may get a little messy. That's going to be my last one. Now I got to clean this up, and this is where we all might make mistakes. The algebra. First, x plus h quantity squared, x squared plus 2xh plus h squared. That is done. Next, distributive property, distribute the 2, except 2x plus 2h. Done. Plus 5. This is lengthy. Now, we're down here, which means some sign changes taking place. You're going to end up with a negative x squared. Down here, minus 2x minus 5. So far, so good. All over h. We did what they said to do. That's difference quotient. Wasn't easily as done as that answer of 4 we got earlier, because this thing's a quadratic this time. Well, some things might cancel. These cancel. 2x's cancel. 5's cancel. Now, can someone in this clever class tell me my remaining terms, and you know what should happen at the end? We're hoping this always happens at the end. Can anyone tell me what might have to be done here in order for that to happen at the end? Go for it.
Is it 2hx plus h squared plus 2?
Yeah, you have to tell me what to do to get there. Don't tell me the answer.
Factor by h.
Yeah, factor out h in those remaining terms on top, that numerator. And be very careful, I'm taking an h out. Still over h, let me step back, I'm on top of the board here. So guys, in those 3 remaining terms, I took out an h. You guys agree?
Mm-hmm.
Am I finally to the point like I should be, am I finally to the point where I can do this?
Yes.
That's what it comes down to. So when I finally do that, which I can now do, final answer, 2x plus h plus 2. Looks strange, but that's the best we can do on this one. That's called the difference quotient. Does it represent something in calculus? It does. Yes?
Tess, will you give us the difference quotient formula?
You want me to give this to you? You want to give this to you? I will. Yes?
How do you do the one that's f of x equals square
Look at you, look at you, look at you. She's one in jumping into those harder problems. I don't blame her. I will not give you a square root on the test. We'll have to do a square root later on in class. So guys, for the difference quotient on the exam, you know, it could be one like this one, which you're hoping it does look like that, because you know the answer's gonna be 4. You gotta make this turn out to be a 4. Or it could be like this business here, and come out to be something a little bit more not as nice looking. 2x plus h plus 2. But be aware of it's one of those, or it could be one of each, like that. I'm not gonna get any harder there. Make yourself a note already. I see my time's running out. I think I mentioned piecewise functions. Did I say something about a sketch? The sketch will be done in class or something like that?
Yeah.
On the review? You need not worry about that. I have not done a piecewise function for you. So don't worry about a piecewise function on the test. I will not give you one on the test. You with me? I think everything else on that review we've done somewhere or the other. I'm proud of you. Now, if, what I think's gonna happen, if I get those top scores, I'm gonna definitely share with my colleagues. Not necessarily your name, just the scores. They will not know who made that perfect score, or that 79 out of 80, or 78 out of 80. I will brag. I wanna make sure I show them, look at my scores here. These students are ready for calculus, getting ready for calculus. Guys, any quick questions? Now, I've got about 4 minutes, and I have not returned the quizzes. You know your score, but I have